Dear friends, we're in the laboratory of Uteca, University of Technology of Azərbaycan in Gəncə City. We will continue our experiments to identify chemicals in foods. We will determine carbohydrates by the method of Bertran, or also as known as the permanqanat method. This method is based on the reducing ability of carbohydrates of phenolic liquid, monosaccharides and some disaccharides, which have free carbonyl groups in their molecule, possess this ability. Carbonyl groups are aldehyde and ketone groups. For example, glucose has aldehyde group and fructose has ketone group. Therefore, are reducing carbohydrates. But the most famous saccharide, sucrose, has no such free carbonyl groups. So, it is not a react with phenolic liquid, or it doesn't reduce phenolic liquid. It is go into the technique of determining and preparing reagents. Phenolic 1. This solution consists of 40 grams of copper sulfate in 1 liter of distilled water. Phenolic 2. The solution phenolic 2. 100 grams of potassium sodium tartrate tetrahydrate, also known as Rochelle salt, and 150 grams of sodium hydroxide are dissolved in distilled water, and the volume is brought to 1 liter. Solution 3. 50 grams of iron 3 sulfate and 200 grams of sulfuric acid dissolve 1 liter of distilled water, or 86 grams ammonium iron 3 sulfate and 108 milliliters sulfuric acid dissolve 1 liter of distilled water. Solution 4. 3.16 grams of potassium permanganate dissolved in 1 liter of distilled water. These are reagents prepared by my assistants. Phenolic 1, phenolic 2, solution 3, and solution 4. We prepare 50 grams of apple. We transfer the taken quantity of apple into a 250 milliliter volumetric flask and pour up to 2/3 of the flask volume with distilled water. We mix the mixture well and heat it at the temperature of 80 degrees Celsius for 15 minutes, shaking often. After complete precipitation, we add the flask to the marks. Mix and filter the contents of the flask. We add 7 milliliters of 30% lead diacetate to the liquid. Mix well and allow to stand for 5 minutes. Lead diacetate precipitates organic non-sugar, such as polyphenols, dyes, proteins. We add 20 milliliters of sodium sulfate to the flask from the measuring by more pipette. The result is such a reaction. 20 milliliter solutions of phenolic 1 and phenolic 2 each, and we pour both solutions into a conical flask with a capacity of 250 milliliter. We, in this flask, add 20 milliliters of filtrate. At the time of draining the solutions and filtrate, such reactions occur. Heated to boiling, and after the first bubbles appear, it is boiled for 3 minutes. The first and second reactions occur when mixing solid solutions, but three reaction takes place after the filtrate is added to the phthalic liquid and heated. We remove the flask from heating and set it in an inclined position for better sedimentation of cuprous oxide. The liquid from the sediment through glass shot filters with fibrous asbestos inserted into Bunsen flask. This flask is connected with Kamovsky pump. When all the liquid above the cuprous oxide precipitate is drained, we add 5-10 milliliters of hot water to this sediment. Water is drained through the filter. This operation several times until the blue color disappears from the wash water. At the end of the wash, we put the filter into another clean Bunsen flask. Then we wash the precipitate in 120 milliliters with a solution of iron sulfate. As a result, the cuprous oxide is oxidized and iron 3 sulfate goes into the iron 2 sulfate form. Here is the reaction. As seen from the reaction, cuprous oxide passes into the copper sulfate onto the same filter to dissolve the remaining particles of cuprous oxide. The amount of iron 2 sulfate contained in the filtrate is titrated by potassium permanganate. It should be borne in mind that iron 2 sulfate is equivalent to the amount of cuprous oxide. That is, 1 milliliter potassium permanganate corresponds to 6.357 milligrams of copper. During titration, the iron 2 sulfate passes into the oxide form. Here is the reaction. As seen from the reaction, iron 2 sulfate passes into iron 3 sulfate after titration. Multiplying the number of consumed milliliters of potassium permanganate by its titer, expressed in milligrams of copper. According to the tables, we find the corresponding amount of sugar. At the end, given the dilutions, we express this amount of sugar in percent. The calculation is carried out so. V1, the volume of the clarified extract in milliliter. V2, the amount of extract in which sugar is determined in milliliter. A, the amount of sugar found from the table in milligram. M, the weight of the sample in gram. Thank you for attention.